Australia. So we visited Australia a little bit yesterday, and we're going to head back there now for a really great event with Jennifer Matthews. Now, Jennifer just did a session with Exploring by the Seat of Your Pants. It was an absolute blast, and I love the name of her talk. I'm going to let her introduce it to you. It's awesome. And she did a great Kahoot quiz with us based on the talk she gave us for students, and it's already been played by students over 20,000 times in the last few weeks, which is really cool. So she uses her knowledge exploring coral reefs to invent new conservation tools to diagnose coral health and rebuild reefs. So a UTS Chancellor's postdoctoral research fellow at the University of Technology, Sydney, she is dedicated to finding solutions to current environmental challenges, targeting local, national, and global topics. So I'm kind of looking back and forth between my two screens until I can get the other webcam set up, and I'm going to bring Jen in with us right now. Hey, Jen, how are you?
Good morning, everyone. Well, it's good morning here in Australia. Yes. I think it's good evening to you guys. Yes, I'm well. How are you?
Good. It's so good to see you. It's been such a great weekend so far. So many great events. And, having you join from Australia from, I guess, the future, it's World Biodiversity Day for you in Australia. So we're looking forward to that tomorrow. But yeah, very cool. Jen, we're thrilled to have you. We're going to let you take over for a little bit, and then I can't wait for a little Q&A action.
Perfect. Wonderful. Thank you so much. Well, it's a really pleasure to be here today. So I am going to talk to you a little bit about coral reefs. So coral reefs and ways to save them. Let me make sure I can click forward on my screen. There we go. So coral reefs, what are coral reefs? Well, they're actually a mix of a number of different species or organisms all in one reef. They comprise of 9 million species. This includes 4,000 fish species, but also 800 different species of corals. And corals are the foundation of coral reefs. They are the ecosystem builders, and they're really important to us, and we are actually intimately connected to the oceans. And maybe you live in the middle of your country and you're not surrounded by coral reefs, or maybe you live in colder countries where perhaps you don't find coral reefs, but you are intimately connected to them. And they help to provide support to us in many different ways. So one of those is wave action. So coral reefs can actually act as a buffer, and they can slow down the action of waves as they approach the shores. And that's really important, especially when we have things like storms or tsunamis. They act as really important buffers for that wave action. They also provide living space for fish and seagrasses that we and other predators like sharks in that photo there that they eat. So they provide living spaces in the context of there's perhaps when fish are really, really small and babies, they provide a nice, safe place to live. But they also provide food for the slightly bigger fish, or even the sharks, and the seagrasses for the turtles. And we can visit them for fun. They're really important to us for the tourism industry, for recreation, fishing, and also for science. So we've discovered some really important medicines from reefs. In fact, medicines for Alzheimer's, for cancer, and for bacterial infections. And who knows, with things like COVID propping up everywhere around the world, maybe we'll find some really important medicines for the next pandemic on a reef. And if we lose them, then that resource isn't there. But what is a coral? Do you think it's an animal, or a plant, or is it just rock? Actually, it's all three. Corals are, as I mentioned, a complex organism, and they're made up of the coral animal, which is actually like a jellyfish. And inside of the coral lives these tiny single-celled plants called algae. And you can see in this image here, I hope you can see my cursor. So the tiny little plants, the tiny little algae, they live in the tissues of the coral. And corals are actually, as a jellyfish, they're colorless and they're see-through. And you can see right through their skin. If they didn't have this algae in, you would see them, they'll be white. But with the algae, it gives them all their beautiful colors. But they can also feed themselves with their tentacles, and they direct food directly into the middle mouth. But a lot of the nutrients they get is thanks to this algae. The algae provide it with key nutrients to grow big and strong, defend itself against infections and changes in their environment. So that relationship with the algae is really important. Oops, how do I get, there we go. And so I'm going to show you some little videos here. You can see the coral is feeding itself, its tentacles. When food moves past its tentacles, tentacles kind of move and they sting, and they put it into its central mouth. So this is a little coral fragment. But those bright colors that you might see, that comes from that algae, and it's no better shown than in this image, this video here. And you can see all the really bright colors. That's thanks to the algae and its tissues. So move on. Corals and the algae, they're best friends. As I mentioned earlier, the algae gives the corals food to make the corals grow big and strong, and the coral provides the algae with a nice, safe place to live. So they live together in this really nice, safe friendship called a symbiosis. And together, the coral and the algae, they can build these huge structures of corals, and all of these different corals together are what we call coral reefs. And in fact, some coral reefs are so big that you can see them from space. This is the Great Barrier Reef in Australia, where I'm calling you from today. But that friendship, that can break down, especially when the water gets too hot. And what happens is that algae is not able to provide the coral with food anymore. And so the coral kicks out the algae. And this means that the coral loses its color. As I said earlier, without the algae, it just looks white. And this is what we call coral bleaching. Now, the coral's not dead, but without its food, giving its from its algae, it's starving. And unless it gets its algae back quickly, then it might die from infections or starvations. And when coral reefs die, when corals die, the entire reef loses its ability to provide that protection and that food to fish, protects coastlines, or provide any medicines. And unfortunately, as a result of climate change, we're seeing the catastrophic loss of corals around the world. In fact, more than half of reefs around the world have been affected since the year 2000. So you can see that on the left is a nice healthy reef, and on the right is where the corals have died. Quite a lot of difference in their appearance. I would much rather visit the one on the left. And so that's where we come in as marine biologists. How do we help them? Well, as I mentioned, the algae gives the coral food. And just like us, corals get protein, sugars, and fats and protective compounds. Maybe you've heard of antioxidants. Blueberries, for example, are full of antioxidants. And these foods, they help corals survive bleaching events or when the oceans become warmer. But we also know so little about what foods provide, what food the algae provide, and how they support coral health. And that's what I study. So now it's time to go diving. And the first thing I do is collect some corals and bring them back to the lab. And here I put them in some controlled conditions and expose them to different environments. And then, so one will be a normal environment, or what we would consider like a healthy environment. And then another would be an abnormal one, like hot water. And then in the lab, we have them here in these, I compare the normal condition corals and the abnormal condition corals. And I measure the sugars and the fats and the proteins in the different two treatments. And then I can find out from this which food best helps corals survive. Another way I measure coral health is from the gases that they release. Yes, I smell coral farts. So perhaps you've eaten broccoli or Brussels sprouts and you have a particularly different smelly farts compared to maybe when you eat bread or chips, your farts smell different. Well, corals react exactly the same. And when they eat really well, they might have one smell. And when they aren't getting enough food or are eating particularly poorly, then they get different types of food and they smell different. And even if you, and I can even sniff out stressed signals of corals directly on the reef. So this is a container here that I put directly over a coral in the reef, and I can use that to diagnose their health. And this is really exciting because we could actually develop tools to diagnose health on the reef at the time that they're being stressed. And this is really important for our conservation initiatives to find and direct conservation onto those corals that are exactly stressed. And another important stage that I help corals is when they are babies. So corals produce billions of tiny babies each year, but less than 1% survive. But we can actually improve that by simply feeding larvae. So here you see a coral and it's releasing all its tiny little eggs into the water column. And when they become larvae, this is what they look like. They start to swim around. So these are tiny babies. And what I've been doing in the last couple of months is finding the different types of food that they prefer. So the best baby food, if you would. So I take the coral larvae and I feed them different foods and I monitor their health after they've been fed and after they have consumed all these different types of food. And I monitor their health with this kind of machine that looks like a disco light. And when they've been a little bit bigger, I put them into a tank and I watch them grow into adult colonies or adult corals. And when they're big and strong enough, then I put them back on the reef. And this is really great because it can actually increase their survivorship by 46%. And that's really important when we're trying to reestablish colonies or entire reefs that have been lost due to climate change. So here we are, we take the coral fragments and we put them into nursery conditions, so little platforms under the water. And then when they get even bigger and they're ready to be transplanted back onto the reef. So these are just some ways that we help corals, but there are some things that you guys can do as well. How can you protect coral reefs? Well, if you haven't already, then try go diving, become a scientist, or even just, visiting your reefs are a really important way of providing tourism and recreation support for initiatives that are using maybe tourism operators or funding that come from tourism. So definitely go diving, but also it's really, underwater world is so beautiful and there's so many different things to see there. And you would never be disappointed by going to a reef. So some things that you can do without going into the reefs is applying your sun cream at least 1 hour before entering the water or using reef safe sunscreen. This helps protect you because it gives enough time for the sun cream to sink into your skin and provide you protection against the sun. But also it means that the sun cream doesn't wash off and onto reefs. And the chemicals that come from sun cream, they can be really damaging to coral reefs. So there's a few different kinds of chemicals here. You can search this online if you don't have time to write these down. But these are the ones that are nice and reef safe, titanium dioxide and zinc dioxide, and these ones are not. So have a look on your sun cream to see if you can find out what it contains. And another way to help protect our reefs is to join or start up your own beach cleanup. And I don't mean starting with 100 people walking down a beach, just you and a plastic bag picking up rubbish on a beach. That's a really great way, because if you don't pick it up and there's a lot of rain, then that rubbish might wash into our reefs, and plastic bags can smother corals and kill them very quickly. Buying seafood and fish that is sustainable. These are really, really easy ways. And thanks to the Marine Stewardship Council, it's made so simple by looking for this image on your seafood that you eat. This means it's been caught sustainably or farmed sustainably. And reducing your carbon footprint to help stop climate change. This is another really important way that we can help protect our reefs, because all of these conservation activities, they're just buying time for reefs. We're not going to be able to save coral reefs if we can't make drastic changes in our climate emissions. So that is all I have time for today. Thank you so much for listening to me, and I'm happy to take any questions if there's anything you have any burning questions.
All right, Jen. We've got a forward-facing webcam now, so I don't have to kind of look back and forth between two different webcams. So that's pretty cool. I thoroughly enjoyed the lesson you did with the students, and I believe we call it all about coral farts. And I know that to no end was very exciting and amusing to students in the classroom. So very cool, and it's just absolutely fascinating. I wonder if you can tell us, if you can describe what a stressed coral's farts smell like.
Well, actually, so to us, we can't smell it. There's subtle,
Okay.
very, very, very subtle changes in the gas content. But when we take corals, and if we're trying to investigate maybe some molecular processes in them, then we have to take fragments of coral into the lab and we remove their tissue. And the smell is so pungent, and these are dead corals. So if you think in a lab, we can smell just from a tiny 5-centimeter fragment how bad that smell is. It really is awful. It smells like rotten fish or rotten eggs. It's really, really disgusting. So it's so pungent from such a small amount. Then on the reef, if the whole reef is dying, then you probably could smell it. But coral larvae as well, when they die, they really stink, really, really like rotten eggs. Yeah.
Okay, the stinky underwater world of the coral reef. Jen, so you mentioned how when coral bleaching events happen, it doesn't mean the coral is dead. If conditions improve, that algae can return and the reefs can survive. But I wonder, how long does it take, and maybe you don't have the answer yet, but how long does it take for those stress levels to fall after a bleaching incident? Like if the algae does return, is it a pretty quick process where the coral kind of just relaxes and continues its thing?
Yeah. So actually, coral bleaching can be initiated by 0.5 degree change in temperature. So one day, for example, when I used to work in Thailand, the temperatures of the waters were frequently around 30 degrees. 31, you're looking at watching the corals for sign of bleaching, but 31.5 degrees Celsius, and they start to bleach. And it's such a huge change in such a huge dramatic effect from such a small change in temperature. But then you get if the water then decreases back to 31, and that can just be one day of a cool current coming through, then the corals will start to regain their algae and they'll survive that bleaching event. But the problems come when these bleaching events are back to back in sense of within the same year or also between years. Before, they were maybe associated with a El Nino event, which typically occurs every 4 years. But now we're seeing coral bleaching even in La Nina events, which is then another 2 years. And in Australia, we've seen coral bleaching back-to-back years, so the last 2 years. And this year was a La Nina event. And that's the first time we've ever seen coral bleaching in a La Nina event. So that's really disappointing. But I think that I think that if the water's cooled down rapidly enough, then the corals should be able to survive. But when there's back-to-back bleaching, and then also the waters are getting warmer, they're going past that 31.5 degrees and they're going to 32, 33, then it takes a lot for the water to cool back down, and it takes longer. And if it's longer, then the corals don't necessarily survive that event.
Yeah. So I know that a lot of the work takes place in the lab. Is there a system for testing out in the field?
Say again, sorry.
I know a lot of the testing takes place in the lab. Is there a system that can be deployed in the field?
Yeah, absolutely. Yeah. So there's these big containers, these big kind of upside down jars. We can take these to the reef and deploy them on top of a coral colony and measure their gas there. So absolutely, there's a lot of stuff that we do directly on the reef, and that's what we prefer to do as well, because we don't really like taking corals off the reef for science purposes. We'd much rather be able to non-destructively sample them and diagnose them. And that's where this smelling their farts is really, really important, because it means that we don't have to, it's non-invasive, and we don't have to kill any coral for the sake of science. And that's really important too.
Yeah, absolutely. So it's hard to be hopeful as a diver myself, and hearing about the loss of coral that we're having around the world. I wonder, what it is that gives you hope for the future of our coral reefs.
I am definitely a climate optimist. I believe that we have, and especially with generations coming through now, and you're seeing it in Australia, for example. We held our elections yesterday, and there was a much larger support for climate change parties, or parties that are showing action in climate change. So I am a climate optimist. I do believe that we will get there, but I think it takes a community to do so. And so everybody can do their part, and all those ways in that last slide that I showed, that you can get involved and help protect coral reefs. Whether you're living directly on the beach next to a coral reef, or if you're not and you're in the middle of your island, or on a cold continent where they don't have reefs, there's everything we can do to help them. So I am a climate optimist, and I do believe that we can help coral reefs, and each in our own way. You don't have to be a marine biologist to do it, but if you want to, that's also a great way.
All right, of course. So Jen, if someone wants to follow your work, what's the best way they can do that?
Yeah, absolutely. So they can follow me on Twitter. I'm at Tiny Scientist. Or if you have any questions about today, then please feel free to email me. You can find my email address by just searching my name online.
All right. So at Tiny Scientist, very cool. Find you online and track it down. Jen, thank you so much for joining us and sharing that story. It's always great to be able to visit the Southern Hemisphere and to take stories from Australia and share them with our global audience. And you're right. We don't always hear the best stories, but you have to be optimistic. We have great research happening. There's solutions being developed. And I think that's what we need to focus on, and everybody playing their role.
Absolutely. Thank you so much for having me today, and enjoy the rest of the festival.
Absolutely. Jen, have a great night, and we'll talk to you soon. Thank you so much.